Hello, friends. Welcome back to the channel. It's been some time. So recently, I had a small problem. So that is like I had around 1.2 TB of data. So there is a message stress marriage that happened on some 6 months back, and we got a lot of footage. So basically, like if there is something like a family event or something, so my parents watch it in an 75-inch TV in the ground state. So my home has two stairs. Like I live in the first floor and they live in the ground floor. So the 75-inch TV, which is 4K, is present in the ground stairs. So usually I have my old laptop. So let me show you that. Okay. So this is my old laptop, if you see. So basically, I run this continuously. So I just keep it on all the time. And I had a jellyfin installed in this laptop, so I can basically put all the video content into the laptop and like serve it to the whole home network. So I had a around 1 Gbps router connected to two routers. One is like to the top floor and one is to the ground floor. So both basically my home is entirely connected via LAN. So I get around 300 to 400 Mbps speed in the home network. But now so the content has become very large, and also like the bandwidth also required more now because it has more 4K videos. Uh, and also one more thing, I am using a 1 TB SATA drive, 2.5 SATA drive to basically to boot from this. There is a Linux instance in it, and I installed Jellyfin in it. So and also like this act as also media drive. So this is a whole thing is around 1 TB. Now the problem is like I had content around 1.5 TB, so I cannot host it using that this particular disk. So I had options now, like I can get a 3.5 inch SATA disk, 3 TB or 4 TB around. It costs around 5,000, and I can put all the content in it and use it maybe by a USB enclosure and connect it as USB into my existing laptop motherboard. So in that way, I can serve the content. But yeah, like I think slowly the amount of content I need to save, uh, and also like the old photos, videos are becoming large. Let's say if I going to some tour or something, I need to store the whole content into some place other than Google Drive, because we know all like Google storage is like around 150 per month, right? It's around 1500, around 1800 around per year. So let's make it like 200, 2K per year. So spending 2K per year on Google Drive for 1 TB data is I am not fond of like doing that, because like ultimately, like if you stop paying, we need to get the data out, and if you don't have any system to store the data, then we are fucked up. So I need something that holds the data. Eventually, initially, now I got around like 2 TB to 2 TB data, like all the data which I have in my mobile, my phone, and and it's gonna increase slowly over years. So I'm thinking to build something like a NAS, a NAS server. I already had sort of NAS, like I had Jellyfin installed, NAS installed, everything in my laptop, but the problem is drives. So my current laptop, like if you see this one, my current mission only has one SATA port here, And there is one more SATA port here, right? There are two SATA ports which can connect to ideally connect to two different hard disks. But if you see, this SATA port is basically a small one, which is like used for CD player. So I cannot power an external die using this SATA port. I need to give external power supply here. Uh, Basically, I can say like this is the one which I can directly connect to a hard disk, and then maybe with external power supply I can use these two disks. Uh, yeah, that's it here. But there is no PCI slot as such, that like if there is no PCIe slot exposed here. If you see, so I can't do much here because there is no PCI slot or the slot here. Like I cannot put something like expansions and all. So I searched internet. I found out one good uh, system that can able to do it for me, and also like low power compared to my laptop. Like there are multiple options here. Like one is a Raspberry Pi. We can use in external SATA hat for Raspberry Pi 5. So there is a Radix SATA hat. Let me show you that. Yeah. So this one I'm talking about. Yeah. So if you see here, let me stop this. So I have like let's say 8 GB of Raspberry Pi 5, and this is around 5,000, and this is around 7,000, coming around 13,000. Sorry, coming around 12,000, and also I need some sort of enclosure. Uh, and I need to put a power adapter. So it's cost me around 15,000 without drives, without any external hard disks. But this will support both 3.5 and 2.5-inch hard disk. So let me show you what I mean. Okay. So this is a large disk which is 3.5 inch, which require 12 volts to work. Whereas this is the small SATA disk. Basically, this requires 5 volts to work. This one requires both 5 and 12. This one requires only 5. So basically you can power this with your laptop's SATA port, but this cannot be powered with your laptop SATA. So you need, but basically like the pin adapter, 24 pin. Basically these pins, both the pins here are same. They both the pin configuration is same for them. Both say you need to you need to have something called external power supply for it. Like there are external SATA power supplies you can get. I will show you what do I mean by that. So but yeah, so this board can support both uh, uh, 3.5 and 2.5 disks. And also like if you see here, you need to stack the hard disk vertically. If you are stacking 3.5 disks which are very heavy, so you need to have some sort of enclosure to attach them and keep them steady. So yeah, so if you like, this hard disk is a 3 TB. This is Seagate. I have two of these. Okay, so it's around 10,000 for hard disks. It's around 25,000 for the whole NAS setup. The hard disk alone cost you 10,000, and this is very clean solution. Like and there is one problem with this solution. Okay, there are like not there are two basically, I would say. One is you cannot upgrade Raspberry Pi, right? You cannot upgrade Raspberry Pi. You cannot change its RAM. Once you have 8 GB RAM, you cannot change it to 16 GB RAM in future. And also you cannot update it processor. The Raspberry Pi processor is like a very compared to general purpose computing. The processor which it has is Broadcom something, so which is like maybe mm, Intel Pentium or something. I'm not sure. So, but it's very even i3 can beat Raspberry Pi processor. Even Intel i3 can beat it. So I don't have like much confidence on like that processor. Even like in future, it definitely it goes uh, out of date easily. So maybe I want to take something like Intel or something, and I need to have configurability in future. Maybe I can upgrade to i5s and that sort of thing. That would be much more better option for me in terms of like future upgradability. So that's why I don't like Raspberry Pi. And secondly, very important thing, True NAS is something we install for the NAS. The problem with the Raspberry Pi is a ARM based, and like there is a lot of open source NAS softwares that doesn't support a Raspberry Pi architecture as of today. So uh, I cannot install TrueNAS into Raspberry Pi. I can install Jellyfin and all separately. I can install a bare metal Ubuntu OS or something, and then on top of it, I need to install the services. But TrueNAS is like awesome. You have like you can run Docker, you can run VMs, and we can run many things inside TrueNAS. TrueNAS as a uh, storage system. Along with it, it has some some packages to we can easily add by just clicking it to make it compute also. That's what I like about TrueNAS, but I cannot install TrueNAS in Raspberry Pi. So that's why I am very uh, pissed off like this solution doesn't work with TrueNAS, and also there is no future upgradability. Uh, yeah, so that's why like I'm making this video. If I'm making a NAS server with Raspberry Pi, I shouldn't have I wouldn't have done this video because like there are a lot of tutorials in internet that already telling the same. So I am using a different approach. So let me show you what I mean. Yeah. So we are using a computer, a general purpose computer here. So you can install whatever you want. So this is an i3. So this is a mini PC, which is like a sixth generation. It has sixth generation Intel in it, and it can you can upgrade it to any. Sorry, this is seventh generation. I'm sorry. This is HP prodesk or Elite Desk. Like both are like almost same. Uh, and 600 G3. So G3 version will support seventh generation, and then there is i3, i5, and i7. It can support all these three. So right now, so this thing generally this used to be used in lot of IT companies like and like around 2016 2017 around that time, and now they're out of date for their use, not for us. Like for us, this is still a pretty solid system compared to Raspberry Pi. So you can find it for second hand in lot of markets in India. So I got this system from Recycle Cart. I will show you like where I'm getting the components, link to the components and everything. I'll put that Excel sheet below. So yeah, now and there is you can buy this without RAM and also storage. So that makes you. I got this for around 4,000 without RAM and without SSD. So I want to be little bit future proof. So I got a RAM which is 16 GB DDR4 in Amazon and installed in this. So that cost around 2,000. So yeah, that is around 6,000 rupees for me to make this system. So I didn't remember the exact the cost number. So let make it like there can be some change. So let's make it 7,000. So my basically this one costs 7,000, which is far more efficient. Not efficient like power wise, Raspberry Pi is much more efficient, which consumes around 5 to 6 watt. But this guy, it on its peak it consumes 20 watt, and if it is idle it basically consumes around 10 watt. So it consumes double for my use case, because like mostly this server is gonna be idle. So lot of nobody gonna use this NAS a lot in the downstage. Even the TV where they don't use jelly film that much. Like they maybe use it maybe once a month. Later in future, they don't stick on seeing wedding videos or any other videos a lot. So basically, this one might they might use once a month or like once 15 days or something like that. Something that sort. So yeah, uh, let me show you the inside. Like there are like okay, so now how would I connect the drives to it, right? How many drives I can connect to this system? Yeah, so very important thing about this mini PC is even Raspberry Pi 2. There is lot of expanders. You have PCI lane. So once you have free PCI lane available, in any of these systems, you can use lot of expander cards in it. There are lot of expander cards that takes a PCI slot and gives you bunch of SATA ports. Okay, so that's what we have seen the Redux hat in the Raspberry Pi. It uses Raspberry Pi PCI 3. I don't know the number of lanes, but with PCI Gen 3 on Raspberry Pi 5, and then use that and give you multiple SATA ports to it. That those expanders are very common. Uh, yeah, so this has an M.2 slot, M.2. So that is very important. When I say M.2, generally like and also the M.2 also a piece sort of PCIe lane. So you need to check what a generational lane that mostly M.2 uses the four lanes. Four lanes, M.2 uses four lanes. That is pretty much the norm. But the generation is important. This guy has PCIe 3 into 4. So exactly same like Raspberry Pi 5. So you get same number of so like if you see PCIe 4 lane, that means theoretical bandwidth for PCIe 3 is like 1 GB for one lane. So if you are using four lanes, it is 4 GB, right? So you have theoretical bandwidth of 4 Gbps, 4 GB per second. Um, so let's say if you're using two drives, two SATA drives, which is like each SATA drive will give you around like 200 to 250 megabits, like read speed. Write is like below than read, so around 250 megabits. So two drives, it's around 500 megabits per second, MB per second. So 4 GB is pretty enough. 4 Gbps is pretty enough for running SATA drives, right? And also like now talking about the network. So this is the network, like you get a 2.5 gigabit connection. So I know like many people are like right now talking about 10 gigabit per second everywhere, right? So so my home system can only support like my main router, which feeds into my TV below, can only support 300 Mbps, right? So there is like 2.5 gigabit per second is overkill. Basically, going for 10 gigabit per second is way overkill. I need to first upgrade my network, which I don't want. Like as of today, only consumer 4K content, like somebody is consuming a 4K from this system is the TV which is downstreams, which when you play it 4K, like it max take 100 mm, it max need 100 Mbps bandwidth to comfortably play 4K video. So I don't think we face any bottlenecks there. Let's say if like 10 people are consuming at the same time from in the network, then that would be a problem because uh, you will get only you have only 300 Mbps max speed. So like each 4K consumption is 100 megabit per second, then you can only maybe three people simultaneously can watch in 4K. So yeah, but I don't have that requirement as of today. So maybe but in future, like maybe we can upgrade this. I'm not sure we can upgrade this. And there is Flex HP Flex IO port connection or something that we can use and upgrade a 10 gigabit LAN port here, but for that I need to change my home network too. I'm not doing that today. So this is like think of this like this. It is more like for one or two people consuming this at a time, and like and also they use photos, videos, different type of content. They do not simultaneously stream 4K from this. So I think this is more than enough for this. So okay. So now I need a way to convert my M.2 slot into SATA. Okay, so there is lot of modules in Amazon. Like there is especially one chip that is ASM1166. So this chip has the capability of converting a PCIe to um, like any of the SATA expansion. I think mostly it's supposed six. I'm not sure about that. It can give you six SATA ports out. I'm not sure, but yeah. But yeah, that is the ASM 1166 is using PCIe Gen 3 and two lines in it. That means we have four lanes, but we are only using two lanes. That means we are like sat. We are not using two more, but I am fine with it. Like initially we thought it is four Gbps is the max bandwidth we get, but we are getting two Gbps, but it's fine. For me, if I use all six SATA drives, 6 into 250, that is around 1500. That theoretically we are back. We are getting like enough speed to run six drives at the same time. Like cheap SATA drives is you will get a, max to 200 MB or something around that type of speeds from SATA. Okay, so let me explain. Like let me open and show you like what changes I did to this. Okay, Ricky. Okay, so this is the fan, which is like very easier to remove. So this is my RAM stick, which is 16 GB, which is overkill for my use, but I just want to like the like 16 GB and then 8 GB. There is not much difference. Like there is 500 to 600 rupees difference. So I just want to use 16 GB in this. In case like I upgrade my processor, I can run one or two virtual machines in it. Like, but as of today, I don't have any such requirement. Okay, let me show you the what other things I installed in here. I need to open the case. Let me open it quickly. So this is basically given for SATA drive, like a 2.5 inch. So you can connect your SATA drive here like this. Okay, so this then you can close this. So you can if you are like if you are using this for some other purpose, not for NAS, you can just use your SATA drive and you can close this enclosure. That's it. Like you don't need to change anything. Maybe you might need to install the RAM. If you are also not buying, you are not buying this with processor also, then I think you need to open the processor and install. And still, like that, you need to open this processor part because like you need to install a heat paste like between the heat sink and the actual processor because they won't come with mostly proper heat paste to it. Okay. Okay, Vicky, let me remove the SATA connector too. Okay, so let's see what I did. So this is the ASM chip I am talking about. So this one is a M.2 PCIe Gen 3 into 4. So this one is what I got from Amazon. So you can, if you see here, there is this small nut. You can just open that nut. insert it and then put it and put it back. So this is one modification I did. And very important thing is the second modification. So this one is not only for this system. Any system that has a PCIe based Wi-Fi card installed in it. So yeah, let me show you this. So this is the Wi-Fi card. Okay, so also have it in my system in my laptop. So if you see this one, so this is a Wi-Fi slot which is connected to a port, right? So you need to see the specification first. Like if your Wi-Fi card is basically PCIe lane, PCIe like it's mostly Gen 3. Like check that in your specifications, it will be Gen 3, and then mostly all Wi-Fi cards are into one. Okay, so when I say into one, there will be one lane. That means you have theoretical bandwidth of around 1 gigabit per second in that lane, right? So, but I have mostly all the NAS systems, and I intended to use this with the LAN, right? Like I don't want to use Wi-Fi because Wi-Fi has a much more less bandwidth than LAN. So I have 2.5 gigabit LAN network here, so I can connect it with my router directly. So I'm not intended to use it for Wi-Fi. So I removed the Wi-Fi slot here and I installed a NVMe drive. That is like I just installed a SSD. Uh, uh, and this is if you see the SSDs like the M.2 or NVMe SSDs are basically larger in size, but this is small in size, right? There is this size of NVMe SSDs, you can get it. But the problem now is the Wi-Fi PCIe slot we are talking has different uh, key than NVMe. Let me show you that. Yeah. Okay. So if you see here, this image, there is different type of key slots. So for Wi-Fi, A plus C, when I say A plus C, if you see here, there are like two notches here, and there are like one, two, three. There are three bridges, like sort of thing, and there are two notches. But when you have a NVMe notch, that is like we called it as M. So there is only one single notch. You cannot take an NVMe SSD and directly put it into a Wi-Fi slot. Theoretically, both are PCIe. One is like generally PCIe lane 4. This is only one lane. But see, PCIe is backward compatible. When I say backward compatible, if you have a PCIe lane 4, that means the your device uses four lanes. You put it in single lane PCIe slot on your motherboard, it still works. But you will only get instead of 4 gigabit per second, you only get 1 gigabit speed. So, but the problem now is the port itself. The port doesn't fit into your NVMe. It doesn't fit NVMe drive, right? So in that case, there is this small converter which is called A plus E key to M2. So basically, what it will do is it will convert the existing slot to different one. So I will keep the link. So first you need to install that. If you see here, put it on Zoom. Okay. If you see here, let me bring it closer to camera. Yeah. So this is my original A plus C slot, which is Wi-Fi slot. And then I have inserted one PCB in here that converts it into M.2. Then I inserted my SD card. So that's how you need to convert your Wi-Fi slot into SD card. So now, why did I do that? Right? I can install my OS in this SATA. If you see here, this is a SATA port. I can use this SATA port and install my OS into the SATA. But the problem is the SATA can give you around 200. 200 Mbps, right? But if you have a boot drive which is faster, your OS is running off your fastest drive, then basically you'll get much more responsive UA as well as everything else, right? Like because you have more storage speed now, like it can boot drive will boot faster and everything. So I want to install my actual OS that is like a true NAS into the SSD. Remember, like this SSD will support up to 4 gigabit. Theoretically, like it can go up to 4 Gbps, 4 gigabit speed. But now it is only giving 1 gigabit, but still it is higher than SATA. SATA can give you only 200 Mbps, but it will like still this one will give you like more than SATA. There are four times, I would say like 4x faster than SATA, right? So yeah, so why not put my OS in it, and because I'm not using Wi-Fi anymore, so I want to use this slot. Okay, so this is the overall modification I did for this particular mini PC. So in the coming up videos, I will show you like how to connect all my drives, and then how I'm changing the OS level settings, and how did I install my TrueNAS into this. And like I want to build a small rack also. Like basically, like after initially I started as a NAS, but then I thought of like why can't I do something like a a home lab setup. So there is this 10-inch rack, something called that is going very viral in the home lab space. So uh, everybody is having a 10-inch rack. Like generally the server racks are around 19-inch in wide. They're very big. So basically for home lab, they're using 10-inch racks, and then they're putting whatever they want. They're putting network switches and all. So I want to create a hard disk enclosure. There is a 3D printing uh, things available for all 10-inch rack and also hard disk slots and all. So I want to bring this project from start to end and build it like a commercial grade setup. So let's see like how that goes. So I gonna make this as a playlist, so you can see the next video in the same playlist.